So this has been occupying a lot of my time the last couple months, maybe 2.5 months. Haven't been doing a huge amount of knife making. I kind of got through the big first batch of knife making, my big first big batch of little Geminis and Skinners, and then I kind of regrouped. I'm going to apply the lessons that I've learned from those to my future knife making. So one of the things that I did was redesign my sander. This is the new sander I'm going to make. Quite similar to the old one, except for some materials. This is going to be aluminum extrusion. I was walking through the store in Wichita, Kansas called the Yard Store, picking up some other materials, and I saw their aluminum extrusion. And I saw how tight the tolerance was, and so I went over and looked at it, and it turns out that a piece of 1.5-inch square aluminum will fit perfect inside of a 2.5 or 2-inch square with a 1/4-inch wall with no slop. I mean, it is extremely perfect fit. It will slide in there, but it doesn't slop around. And so I went ahead and they have good prices. They have great prices there on aluminum, actually. So I went ahead and bought enough aluminum to make 2 sanders. And this is I came up with this clamping system here. I've converted my MIG welder so that I can weld with aluminum. So I'll do a little aluminum welding, weld these brackets on here. I'll cut that slot on my table saw. All of this can be cut with a Diablo non-ferrous blade. Cuts it really good, actually. I've cut one of these already out. I haven't assembled it all yet. I redesigned the platen, kind of made it a little bit smaller, came up with a couple of guards. I chopped off my tensioning arm. This used to stick out here about another 4 inches and had a spring that would come down. Let's see. This back here is pretty much all the same, the drive system. The big changes were in the tensioner, and then what I've done here, this is my new tensioning system. I went ahead and put a handle on it. Like I said, ditched the spring, and I've got designed this piece here. So when you put your belt in, then you just push up on the handle to tension the belt, and then the cog and the latch will hold it in place where you want it. And then when you're done, you lift up and pull back on the little paddle, and it releases it, and you can change your belt. This is going to be a big improvement here. I have already built, let's see, I welded up the vertical frame and the base frame, and I did weld up one of these, and it makes it really, really tight. I mean, it's nice. This will slide in and out good, but just a tiny little twist on here, and you get the clamping for that 10 inches of holding that mount there. You got 10 inches of metal clamping down, so it's really snug. It's tight. There's no wobble. What I was experiencing before, because I had used that steel pipe, so I had a 2-inch steel pipe, but it had like a 3/16 wall, and so when you put a 1.5 in there, it would flop around by about 1/8 of an inch. And then also it had inside, of course, there was when you get pipe like that, it's not square. It looks kind of square. It's square enough, but it's not square. It's not precision square like this aluminum extrusion is. And so you really have to watch when you're putting it together. Anyway, and then inside of it, it has a seam where it's been welded because it's been folded over, the steel pipe has, and then welded down a seam. So you have a seam in there to deal with in addition to the sloppiness. And so that sloppiness was in here, and it was in this mechanism on my current sander, and so it would slow me down when I would want to make changes, because I would have to be very careful to get all the slop out in the same direction every time to get consistent results on my bevels. And so I went ahead and designed all that out using this. This comes in square corner or rounded corner, so I'm going to use the rounded corner inside. The square corner actually does slip in there very nicely as well. I'm just going to use the rounded corner because no special reason. If there is a special reason, I haven't figured it out yet. I just decided I want to use rounded corner on those parts. Maybe there's subconsciously a special reason, but I can't think of it. This is something new that I wanted to try on my platen. This is going to be a profile, a little profile plate. Let's look at it from the edge. So it'll profile right there instead of having a harsh cut at the ricasso for my plunge. Some of them I want to blend in, and so I'm going to experiment with this to see how this will work out by blending in the ricasso area. And what I'll do is I'll get a lightweight belt, something thin and that's real flexible, and I'll roll it out. I'll use the tracking wheel to move it out over here past the edge of that, so when I come in, the belt will kind of roll around this radius a little bit and give a blended sanding at the ricasso area. That's an experiment. I hope it works the way I think it should work. This is the bevel sander, the bevel jig, bevel grind jig, whatever we're going to call that. That thing is, the design is finished. I've actually posted it on my web store and sold a bunch of them already. 5, that's a bunch. This isn't the final one. I haven't updated this print yet, but while I was home this last time, I went ahead and cut this part off of my current bevel jig, the one I had made out of steel. I took it apart and cut that off, and then what that allows me to do is rotate the platen a lot farther over, because the platen will rotate here. It'll rotate it over far enough that I can actually now do the secondary bevel, which is the cutting bevel. So I can go this is a full bevel solution right now. I can go from an unground knife blank, I can grind the primary bevel, and then by having this cut out of the way, I can rotate the platen a little bit farther and get nice secondary bevels on there. What I've done so far, I've done it on one knife just to kind of test out the concept, and I put a 600. Let's see, started out with like a 320 and put the bevel on there with the 320, and then I touched it with a 600, and then I hit it on the leather wheel, and it came out real good. And so what I'm going to do is get a leather belt. Actually, you can buy 2-inch leather belts, 2x72 leather belts, and so I'll put one of those on here, and everything will be on this machine then. In addition to that, let's see, I am working on this idea here. This is the machine with the hollow grind contact wheel on it. There's a 10-inch wheel that I use to do hollow grinding. It goes in place of the platen. It's just pull it out and plug it in. It's very quick. But this thing is going to be a surface grinding attachment. You can see here that it will transit in and out on I just put the bevel jig in there for now, but it'll be a similar thing to the bevel jig that will push it in and out to the wheel. And then what this is 8020 website. You can download tons of CAD files, which is awesome. And so what I got a piece of their extrusion there, and some of their gussets, and one of their linear bearings. This is one of their linear bearings right here. And then on top of it, I bolted this plate mechanism so that it will tilt out at the bottom. It'll hinge right here and tilt out at the bottom. And also I've got another one tilt this way. I may get rid of this one that tilts side to side and just go with it bottom tilted. Anyway, this is going to be a surface grinder, so you can grind the thickness of your blade, And by having it tilt out, and then this table mechanism is sliding up and down, you can do tapered bevels. I mean tapered, like tapered tangs. You can do a distal bevel on your blade. So there's a number of there's quite a few possibilities there, and probably some more that I haven't thought about. And once I get into it, I'll start seeing what its capabilities really are. But I got that idea from looking at the TW90. He has a real cool surface grinder attachment for his sander over there, and so that's where I got that idea from. So I've got 2 attachments on there at the moment.